Hello and welcome to the Varonis Atlas demo. Let me show you the absolute fastest way to make AI systems secure, compliant, and trustworthy across their lifecycle. With Varonis Atlas, I'll walk you through a brief demo of the Atlas AI security platform and how we provide visibility, but go beyond to enforce policies, block out of policy actions, remediate risk, and alert to threats where other tools simply stop at visibility. I'm going to walk you through several scenarios that will show you the different elements of the platform, starting from the discovery of AI resources, where they come from, what projects they belong to, into AI security posture management, or AI SPM, where I can assess and pen test my AI resources. Then, I'll effortlessly establish runtime controls with our AI gateway in order to secure my AI. And finally, I'll use all this information in order to automate my compliance process. First, let's log into the system and go into the AI 360 page. Here I see the state of all my AI in the company and the total risk score of my AI deployments. I can see this at the organizational level, or I can see it at a certain project level. Here, for example, I have a project where I don't have much risk. But when I look at the full organizational level, I can see I have some shadow AI issues, but I'm doing quite well in my compliance progress. Scrolling down the dashboard, I can see the breakdown of issues across my organization produced by the Atlas AI Gateway, pen test, and vulnerability scans. I can see exactly where I should focus my time. I'll start by understanding what exactly is going on with Shadow AI by clicking on the widget. I'm taken directly into the AI inventory, where I can see all the models, software, and inventory that are unsanctioned or not in the catalog, and maybe shouldn't be used at all. For each rogue agent or resource, I can click on it to get more detail. I can see which project this agent is in, whether it is active or not, and the source it was discovered in, and much, much more. Scrolling down, I can see threats found related to this agent. The graph shows me all the components that make up this agent, including other LLM tools and MCP servers. Indicators show me which components have issues. I can click to go to the AI SPM module and see what the issue is. From here, I gain a deep understanding of what I need to fix. In this case, there is a possible tool poisoning that's occurred with hidden instructions sending extracted information to an external email address. I'll assign it to someone later. But for now, let's go back to the AI inventory, where I see an all-encompassing view of my AI cloud assets, models, software, AI services, endpoints, and truly any ingredient of an AI system within my environment. Best of all, this inventory is created simply by connecting to services in a non-intrusive and agentless manner. I can easily scan my infrastructure where I develop and deploy AI systems. I can also scan my code repositories in GitHub and Bitbucket, as well as connect to hosted AI services. Varonis Atlas covers everything and builds a master catalog of all AI inventory in an automated and continuous manner. No more filling in spreadsheets or forms or chasing people around. Updates are also made continuously, and it pulls all the information that I need. For example, I look at my model inventory, and this is not something I recognize. What is this Google ML model? Where did it come from? I can drill down and see where it's being used and how. I can also view the model card for more details about the model, such as how it was trained and the model architecture. Let's go back to AI SPM. Here, I can easily visualize and manage all of the vulnerabilities and misconfigurations of my AI resources in a single place. CVE findings are generated automatically and grounded in the NIST vulnerability database. The pen test findings here are driven by pen test jobs, which I'll get into in a moment. I can also enable policies based on leading standards and best practices for configurations, sensitive data scanning, and agentic threats grounded in OWASP risk. Now, I'll click on the Issues tab, where I can view all of these issues in a list format. Let's take a look at this TorchServe vulnerability. I can click on it to see an overview of the CVE finding. It contains a full description of the vulnerability, the particular version of TorchServe that's affected, and links to the National Vulnerability Database entry and the CVE score. I can click on Assess to see additional details about the vulnerability, including an attack diagram showing the anatomy of the attack. But most importantly, the system provides the ability to remediate the vulnerability in all of the different files and repositories where it exists. I can immediately create a pull request in this GitHub repository. Switching gears from the CVE findings in the Issues tab, let's also take a look at the sensitive data issues before we get into pen test. These are all of the instances of sensitive data discovered in the datasets that exist in this project. And let's take a look at one of these Jupyter notebooks, where sensitive data was discovered, and let's drill into it. When Varonis Atlas discovers sensitive data in notebooks, it's able to tell you specifically which cell in the notebook the finding was discovered in, as well as the types of PII that were identified in that cell. Now, I'll show you one of the proactive capabilities to fix issues before they become breaches or fines, and that's pen test. Establishing these tests takes seconds with minimal configuration and can be automated as well. During staging and development, when I download a model from, let's say, Hugging Face, I can scan it and make sure it's safe before I start using it. Or I can pen test an LLM endpoint before deployment. Best of all, I'm able to automate pen tests by scheduling in advance or based upon a preferred cadence. When I'm done, all the information is in one place, and I can easily view the results. In this case, there are issues with prompt injection, jailbreaking, and malware creation. I can also download a report to give to my stakeholders. This report will show the team exactly what tests were run, what the failures are, and recommendations on how they can mitigate the issues. But if they can't get to it immediately, I can help them by applying guardrails in the AI gateway. For some of the issues that might exist, whether I need to prevent sensitive data leakage or block malicious and non-compliant use, there are guardrails within Varonis Atlas to protect my AI systems. And you may be asking yourself, how is this deployed? There are 3 possible deployment options. This gateway can be deployed as an Nginx reverse proxy, hosted in Docker, or a Python SDK is accessible for customers who can't use a proxy. And customers with an existing API gateway like Kong or Apogee can configure it to call the Varonis Atlas firewall APIs directly. Furthermore, proxy chaining is also supported, and the SDK can be ultimately integrated into a customer's own API gateway flow. As shown, some of these guardrails are input guards that are applied to the prompt at runtime. They evaluate whether or not it's an attempt at prompt injection and stop it before ever sending it to the model. And output guards are applied to the responses, as you would imagine. Atlas gives admins the seamless flexibility to choose which guardrails to apply, either at the project level or at the company level, to make sure that every project is in compliance. Different types of guardrails can have different types of rules. Jailbreak rules will be set to block, alert, or log. PII rules, for example, can have a modification action, which means that if I see PII, I'm going to redact it so that it doesn't leak out. Guardrails are also available to limit which actions an agent can take, or the resources or tools it can use. Now, let's look at how AI Monitor complements the AI Gateway. It gives me observability into my guardrails along with quality and performance metrics for every enabled rule. For each configured endpoint, I can see a visual breakdown of which rules have fired. For example, the prevent prompt injection rule enabled for this OpenAI API key. I can view this data over time and see how often a rule like prompt injection is triggered. One useful feature here is that I can configure alerting directly from the widget. So when this kind of anomalous behavior occurs at a certain rate, the right people are notified to investigate and take action. On top of all that, the AI Monitor module includes its own set of organization-level policies, such as sentiment analysis, hallucination detection, and much, much more. These rules work differently from the standard AI Gateway rules. They don't have enforcement actions that I can configure, like blocking, but instead are used to tag inputs and outputs and drive additional alerting and monitoring within the AI Monitor dashboard. One last element of visibility and control before we discuss compliance is AI usage. The AI usage module gives me session-level visibility into how users are accessing public AI applications or services over the network. This information is gathered from a network log push from network access suppliers like Zscaler, Netskope, or Cloudflare running in the environment. Here I can see the public AI services my users are accessing, like ChatGPT and Claude. I can maintain policies that will generate issues whenever someone accesses an unauthorized application. And I stay in control of which AI services are authorized or not. So we've covered a lot so far. I have my inventory mapped and under control. I'm slowly reviewing and removing my shadow AI, know the security posture of my AI system, and I've now put in active runtime controls. I'm ready to let the system generate everything I need to pass my audits and meet all my compliance requirements. Let's go to the compliance module. When I click on the Compass tab, I can see where I previously set the jurisdiction to the European Union. Based on that, Varonis Atlas identifies the applicable compliance requirements. As a high-risk EU deployment, the system must comply with the EU AI Act. I may also choose to complete an ISO audit, either to meet internal requirements or to give my customers added confidence. In this module, I can initiate a new audit, see active audits underway, and generate reports for completed audits. We've discussed our compliance, but what about our vendors and their use of AI? In our final module, AI Third-Party Risk Management, or TPRM, we can onboard vendors and initiate a survey workflow with them to understand our potential inherited risk. Once the vendor finishes the survey, we can see the high-level details and understand issues flagged by their responses. We can easily see the issues, such as how this vendor manages our data in the event that the contract is terminated, along with other possible compliance risks. In addition to the survey, vendors provide an AI bill of materials. So we can begin scanning those for potential CVEs within our AI SPM module. These resources are continuously scanned for new vulnerabilities, ensuring your team is consistently aware of supply chain risk. Most AI security tools focus on a single piece of the problem, resulting in fragmented visibility, reactive controls, and blind spots across AI build and runtime. Varonis Atlas is the complete AI security platform that secures everything you build and run with AI, across the entire AI lifecycle with a single simple control plane for AI risk. I hope you've enjoyed this short demo showing how fast and easy Varonis allows your AI and security teams to get started securing AI throughout the enterprise. Get started today by scheduling a more in-depth and tailored demo, or get your hands on Atlas today, rather in a robust lab or in your environment, through proof of value. Thanks.